Now we've got our RBD system set up and ready to go. We've got that working perfectly. So we need to go ahead and start our flip simulation. So up till now in week 4 and 3, we were sourcing fluid into our simulation. We were bringing in the particles frame by frame into the sim. So we're going to do something different today. We're going to be using a tank. So we'll have like a pool of fluid from the get-go at the beginning, which will be waiting for the RBD strawberries to collide with them. Okay, so the sourcing is going to be a bit different here. It's not a source really, it's an initial state for the flip solver to use, right? So let's go ahead and build that first. So just like with the source, we build it here in SOPs. I'll bring a geo and I'll call it fluid initial, like that. Dive in there, and then it's a bit strange because we're going to be using the ocean source. Now we're not obviously generating an ocean, however this is the node that we need. Okay, so we're going to be creating a tank, yeah, like a tank of fluid. We do have an error here because as the node suggests, it's for creating oceans and it's expecting SOP nodes which are used to generate waves and such. So we're not doing that. So if we come over here to surface evaluation, you can see type here. We got ocean, and if we read the information, the type of surface to evaluate, ocean or flat, right? And then you can see there the parameters for flat type are from an embedded particle fluid tank SOP. So we're doing a particle fluid, right? So let's go to flat. The error is gone and we get these particles there. Okay, so yeah, the idea is the strawberries will fall and collide with the fluid, these particles there, okay, within these boundaries. So let's take a look, another couple of parameters which are important to us. So we're going to be creating particles, right? The water level, we can change where this is. I'll leave that at 0, however. The layer size, so we've got this layer of fluid at the moment. There. Okay, I'll leave that again at 1 for now. The water level we've done, sorry. So yeah, one thing we need to do is fill the volume. So we got fluid going all the way to the bottom. And something strange you'll notice there. So when I click fill volume, we'll have fluid going all the way to the bottom, which is what we want. Otherwise the fluid will just drop at the first, from the get-go. But we don't want that. We want it to be full from the beginning. And now if I click this narrowband particles, you can see it disappears again, right? So this is kind of a handy feature where we have a volume representation, or well, just a volume from here down, where in fact the whole thing will be a volume, but the particles are very heavy on your RAM. So at the surface where detail is very important, we keep particles and we use the particles for evaluating the surface. And then underneath that we have a velocity a volume which takes the velocity from the particles and passes it back. So we're saving a lot of RAM here by just basically deleting those particles, but it will behave as a solid piece of fluid, right? And we can play around with the layer size there. We'll probably be bringing that way down or growing it bigger, right? Particle separation, if you remember, is the very important thing which guides it's like the resolution, So coming from here, we have, if I drop a null, this will be, where what we will feed into the DOP solver. So here we've got, if we click on the information, we can see we've got points, particles, we got position, sorry, and we got particles, points there, and we got one volume as well. So you can see we got this surface volume, which is 50 by 50 by 50. Okay, so that's what we're getting out of here, right? So we need to split that up, and we can do that by, well, maybe we can use a split actually, which just looks a bit neater. Just drop a split node, come here, and if we grab the surface, then out here we don't see anything, but we can see now we have the surface but no points. Well, 1 point which represents the surface. So I'll put here caps lock surface, and then here the particles equals, okay. So that's basically what we need for our emission. So not the emission, sorry, the initial state. This is not an emission, and we'll just be playing around with these parameters, right? We'll be connecting the size and the center probably up to the flip solver in the DOP network. Also the particle separation, maybe a few other things in here. We can go ahead and build that really quickly now, just so we can connect them up and then start to refine the parameters. Obviously the scale, you can see that we need to bring that way down, but we'll do that in a moment. Right, so let's build our DOP network. I will put that there. I'll put flip sim, why not? Dive inside. So the same as before, we obviously need a flip solver. Connect that up. We need some gravity. Drop that in. We get an error because we got no object. We need our flip object. The same again. Connect that up. You can see, over time, after building these DOP networks a few times, you can see doing the same thing many times. You've always got an output. 9 times out of the time you want gravity, some kind of solver, and then some kind of object, and then you're adding extra bits and bobs into that to do whatever you need to do. So here, if we look at input type, you can, if you remember, we used that narrowband thing in the initial there. We use narrowband. Okay, so that's what we're going to use here. We're going to switch this to narrowband. Okay, and it's still trying to use this default thing, which doesn't look great there. So let's go ahead and find the, where is it? Fluid to initial, and here we need the particles for the SOP, right? And then here we can see it tells us surface volume. So let's go ahead and find the surface, connect that up. Again, these sprites, you can see these are like images of particles, which are unnecessary. It's just too heavy on your graphics card. So put these two particles, be way faster. You can see there that was slowing down as I was just trying panning around. Cool. Let's split this up. So I'm going to go to split pane left and right. So I've got two network views. I'm going to click on, well, both the pins are checked, make sure is the same. Okay, so that when I head out here it doesn't change there. I'm going to jump into my fluid initial, press P there to bring up my parameters again, and then we can connect up these parameters. So I want to control the particle separation from here. So I'm going to right click, copy parameter. Again, we've done this many times, and the more you use Houdini, you see how useful this is. Paste relative reference. So now I can drop this down here. I'll do 0.5. Okay, and there we go. Let's see what else we want. I'm going to control the size, I think, from here, so kind of in reverse. So that we need to go to in the flip solver, volume motion, and this is the actual size of our box here. So I'm going to take our size, copy parameter there, paste relative references. Okay, so we got 555, and the same with the center. I'm going to copy that parameter, box center, paste relative references there. So we got all that set up. And in the next class, we'll look at maybe bringing in those strawberries, see if we can actually get a collision with this.